Let us see the next topic, reaction towards hydrogen. So group number 16 elements, that is oxygen, sulfur, selenium, tellurium, polonium. Here we are not studying for polonium because it is a radioactive element. So group 16 elements, they react with hydrogen and they form hydrides. Now what hydrides they are forming? They form the hydrides of EH2 type. EH2 type. So we will write the hydrides here, H2O, H2S, H2Se and H2Te. They are the hydrides formed. Correct. So these are the hydrides formed. Now let's check their characteristics. Characteristics of hydrides formed in group number 16 elements. So the first characteristic, that is acidic strength. So acidic strength, it depends on electronegativity. It also depends on donation of H plus ions, which will give H plus ions very easily. Correct? The simple definition of acid, the substance which gives or donates H plus ions very easily. They are called as acids. So down the group, what is happening here? Hydrogen is combining with oxygen, hydrogen is combining with sulfur, with the selenium, with the tellurium. So see down the group what is happening. Hydrogen size will remain the same. Correct? Hydrogen size is remaining the same. Oxygen, sulfur, selenium, tellurium. What is happening? Size is increasing. So oxygen almost the same size of hydrogen. Sulfur little bigger than oxygen. Selenium little more big than sulfur. And the last one, tellurium little more big than selenium. Correct? I'll just write here, this is for oxygen, sulfur, selenium, tellurium. These all are hydrogen. Correct? H2O. So you can here also you can make one more H. Correct? H2S. So here also. H2Se. So here also. Here also H. Correct? So hydrogen size is remaining the same. Down the group, the size of the elements is going on increasing. Correct? It is going on increasing. Now check here. Over here the bond length is less. We'll compare with oxygen and tellurium hydrides. The bond length over here is less. Bond length less. In case of oxygen of hydride form. Tellurium, the bond length is more. Why? Because the size is more. Correct? Bond length is more in case of tellurium hydrides. Why? Because the bond length is more, because the size is also more. Size is bigger. Correct? So if the bond length is less and more. Now see the definition here, which gives off H plus ions. So down the group as you are coming, the bond length is increasing. Down the group, the bond length is more, the bond length is increasing. If the bond length is increasing, you can easily break the bond. Correct? If the bond length is more, you can easily break the bond. So easily you can give off H plus ions. Correct? Because the length of the bond is more, less energy is required to break the bond. Just take an example of a thread. If I give you a long thread, easily you can break it. Less energy is required. But if I give you a very small thread, then you will struggle to break it, right? Very small thread means you will struggle to break it. So here in case of tellurium, the bond length is more. So easily you can break the bond of hydrogen and tellurium. So bond enthalpy is less energy is required to break the bond. Therefore, hydrogen ions will be given off very easily in case of tellurium. But see in case of oxygen, the bond length is very less, small bond length. So it is difficult to break that bond. More energy is required to break the bond. Correct? Therefore, down the group acidity increases. Down the group acidity increases. Why? Because see the reasons what we have written. Because easily tellurium and hydrogen bond can be broken. Reason is bond length is more. That's why. Correct. So down the group acidic strength is increasing. Okay, let's check for electronegativity also. Oxygen to tellurium, which is more electronegative? Oxygen is more electronegative. Down the group what is happening? Acidic strength we are talking. So down the group electronegativity is also decreasing. Let's check the order of the hydrides here according to acidic strength. So H2Te will have more acidic strength. Correct. Let's check the order here. So H2Te will have more strength, acidic strength than H2Se, than H2S, than H2O. Correct. In case of the group, when we are talking of the hydrides, water is the weak acid, H2Te is the strong acid. So just make a note of the order here. Yes. So let's move to the next characteristic, that is thermal stability. The second characteristics, thermal stability. Thermal stability means what? The amount of energy required to break that bond. Correct? The amount of energy required to break that bond. How much it is required. So check down the group again. Hydrogen and oxygen both are small. So small and small atoms, when they are combining, they will form a strong bond, and that bond will be stable in nature. So we have seen here, over here hydrogen and oxygen almost same size, then hydrogen and sulfur little big size, hydrogen same size, selenium little more bigger than sulfur, hydrogen and tellurium little more bigger than the other elements. So what is happening down the group? Size is going on increasing. Here the bond length is very small in case of oxygen and hydrogen. Correct? Bond length is small bond length. But here in case of H2Te, the bond length is more. So the bond enthalpy is less. The bond enthalpy is less. Less energy is required to break the bond in case of hydrogen and tellurium. Less energy is required. This we have discussed the previous topic also. So thermal stability, small if they are making a bond. Remember this, small atoms, when they are making a bond, the bond will be stronger and stable. It will be stable. If a small atom and a big atom, they are making the bonds, then the bond enthalpy will be less. Correct? The bond will be weak bond, and it won't be stable. If it is big atom means it will be stable. So small, more stability is there. So thermal stability order, if you write, means water more stable than H2S, which is more stable than H2Te, which is more stable than H2Se, Te. Correct? So note this order. So why H2O thermal stability is more or higher than the other hydrides? Because of the size. Small and small. Hydrogen is small in size. Oxygen is small in size. Moreover, it is also forming hydrogen bond. Okay. If hydrogen combines with three elements FON, fluorine, oxygen, nitrogen, then we say it as a hydrogen bond is formed. So H2O is having hydrogen bond also. Hydrogen is small in size, oxygen is small in size, and because of this reason it is stable. So more energy is required to break the bond in case of water. So the order goes in this way. Just make a note of this. We saw about the acidic strength and the thermal stability. So acidic strength, it increases down the group, correct? And thermal stability decreases down the group. So let's check the next characteristic here, that is melting point and boiling point. The third characteristics of the hydrides, melting point and boiling point. So melting point and boiling point, it always depends on the van der Waals force of attraction and mass. So down the group as you are coming, we know the mass is increasing, van der Waals force of attraction exists, mass is increasing, correct? So MP and BP will also increase down the group. So MP BP of H2TE will be the highest, correct, than H2SE, than H2S. Now where should I write water here? Water melting point, boiling point will be more than H2TE or it will be the least? No, I'll write it here, water. Why is it so? Because hydrogen bond is present in case of H2O. Correct? Hydrogen bond, it is a strong bond. More energy is required to break that bond. So order it is same like H2TE, H2SE, H2S, only water will come in the front. Why? Because it has hydrogen bond and MP BP of water will be more compared to the other hydrides of the group. So we have completed with the hydrides topic, its characteristic also. In the next video we will see the reactivity towards oxygen. Thank you.